Welcome to the podcast Day Philippe, where we like to call this segment a deep dive.
Yes.
And today,
Deep dive.
we are diving deep into the world of AI,
Right.
and specifically AI that can design materials. And you may be saying, well, what does that even mean?
Yeah.
But get this, we're talking about AI that can design materials for things like better batteries and solar panels.
Right.
So this is the kind of technology that could really change how we power the world.
Absolutely.
That's pretty incredible stuff.
Yeah.
So we're going to be looking at this tool from Microsoft called MatterGen,
Okay.
and we're going to unpack how it works, what it's already achieved, and what this all could mean for the future of renewable energy.
It's a very, very fascinating topic. And,
Yeah.
and it's really exciting because it's not just theoretical.
Right.
MatterGen is already showing some impressive results. And I think that's what makes it so interesting. You know, it's a generative AI.
Okay.
And what that means is it can actually create new things.
Right.
And in this case, it's creating materials with properties that are fine-tuned for a specific purpose.
So it's not just like, tweaking an existing formula a little bit. This is like dreaming up a whole new material.
It really is, yeah.
So how does that even work?
So imagine you're trying to find the perfect combination of elements for, let's say, a more stable battery.
Okay.
Now, traditionally, scientists would have to go into the lab and synthesize and test, countless variations, and this could take months or even years.
Yeah.
MatterGen, on the other hand, can analyze huge data sets, and it suggests thousands of potential options
Oh.
in a fraction of the time.
Okay, so it's like this super-powered research assistant in a way.
Yeah, exactly.
So it's speeding things up, but how is it different from what, scientists have already been doing for a long time?
Well, it's not just about speed, although that's a huge advantage.
Yeah.
What MatterGen does is it uses these really complex machine learning models, and they can actually predict how different elements will behave when you combine them.
Oh, wow.
So you can think of it almost like a high-tech detective. It's guiding researchers toward the most promising clues, but in this massive chemical landscape.
So instead of like randomly throwing things together and seeing what sticks, it's like
No, it's much more targeted.
actually thinking about it
Exactly.
and being smart about those choices.
Yeah.
Now this might sound like, okay, well, are scientists going to be out of a job then if we have these robots that can do all this work?
I don't think so, no.
Okay.
This technology, it's meant to really complement human researchers, not replace them.
Got it.
And what MatterGen does really well is it speeds up those initial exploration phases.
Okay,
Does a lot of that, heavy lifting when it comes to calculations and predictions.
Right.
But you still need that human intuition and creativity
Yeah.
to interpret those results and actually design those experiments.
So it's kind of like a partnership,
It is.
like a powerful partnership,
Yeah.
right?
Yeah.
Okay, so, we've got speed, we've got efficiency, but what other benefits are there to this whole AI-powered approach?
So one of the biggest ones is cost effectiveness. Okay.
Because AI can test so many possibilities virtually.
Yeah.
You don't have to do as many physical experiments, which are expensive,
Right. That makes sense. Yeah.
time-consuming.
Yeah.
And what's also really interesting is that MatterGen can actually identify combinations of elements that human researchers might completely overlook.
Oh, wow.
So it's not just about doing things faster, it's about actually expanding the realm of what's possible.
Okay. Yeah. That's really cool.
Yeah.
Now, this all sounds good, in theory, but is there any proof that it actually works?
Oh, absolutely.
Okay.
So Microsoft claims that MatterGen is creating these crystal structures that are 2.9 times more stable
Okay.
than what was possible with previous models.
Wow.
And what's more, these structures are 17.5 times closer to what's called a local energy minimum.
Okay, hold on.
Yeah.
Local energy minimum. What is that?
So imagine you're rolling a ball down a hill.
Okay.
It's going to naturally settle at the lowest point it can find,
Yeah.
right?
Yeah.
So in the world of materials, atoms behave kind of similarly. Okay.
They're looking for the lowest energy state
Okay.
to become stable.
Right.
And what MatterGen is really good at is finding those low energy states.
Got it.
So it's essentially creating materials that are more likely to actually exist and hold together in the real world.
So it's not just like, coming up with these crazy ideas. It's like
Yeah.
actually making sure that they'll work
Exactly. Yeah.
and that they're stable.
Yeah.
Okay.
And this is particularly important for something like battery development,
Right.
where stability is absolutely paramount.
Yeah, you don't want your battery exploding.
Exactly.
Okay, so it's not just about, tweaking existing materials. It can actually create new ones.
That's right.
It can create materials we've never even seen before.
Yeah, using elements from all across the periodic table.
Oh, wow.
So it really opens up a whole new world of possibilities.
So what kinds of properties are we talking about here?
Well, things like high magnetic density, specific electronic characteristics, or mechanical properties. We can actually tell MatterGen
Wow,
we need a material that does this,
that's crazy.
and it can explore those possibilities.
Okay, so it's like a custom material shop.
It kind of is.
This is amazing.
Yeah.
So how does this all tie back to our original focus, which is renewable energy?
Well, imagine you want to develop a battery that charges faster, lasts longer,
Yeah.
and uses more sustainable materials.
Right.
MatterGen could be the key to doing that.
Okay.
It allows us to explore so many combinations
Yeah.
and potentially revolutionize the way that we design and build everything from those batteries to solar panels.
So we're kind of like pushing the boundaries of what's possible in this whole world of renewable energy.
Yeah, we really are.
Now we're just kind of scratching the surface here.
Oh, absolutely. There's so much more to this.
Okay, so you mentioned earlier that MatterGen has already achieved some really impressive things. Can you give us some specific examples?
Well, one thing that really stands out is that MatterGen doesn't just come up with ideas.
It actually checks to make sure that those ideas are viable.
Oh, okay.
And they've been doing this using something called density functional theory, or DFT calculations.
Okay. I'm going to need you to break that down for me.
Sure. So basically, it's a well-established method in material science,
Okay.
and it helps to predict how materials will behave at the atomic level.
Got it.
And the fact that MatterGen's results are lining up with these calculations
Yeah.
gives us a lot of confidence that this isn't just some, fancy algorithm spitting out random combinations.
Right.
There's real science behind it.
There's a method to the madness.
Exactly.
Okay, so what are some of the specific things it's been able to produce?
Well, for example, it's shown that it can propose structures with a very high magnetic density,
Okay.
but using chemical compositions that have a low supply risk.
So that means you could create like a really powerful magnet
Yes.
without needing those rare earth elements that are so environmentally damaging to mine.
That's exactly right.
That's amazing. And that ability to design for multiple properties at the same time is incredibly valuable for solving real-world problems, because you don't just need a material that does one thing well.
Right.
You need a material that can kind of multitask.
Yeah, that makes sense.
Yeah.
So let's bring this back to our initial question. How could this technology revolutionize how we power the world?
Well, imagine being able to design a battery that charges in minutes instead of hours,
Go.
or a solar panel that can efficiently capture energy even on a cloudy day.
Wow.
That's the kind of potential we're talking about.
So it's like taking what feels like science fiction and making it a reality.
I think so.
This is amazing.
Yeah.
And this is really just the beginning.
This is just the tip of the iceberg.
There's so much more to explore here.
Absolutely. It really is remarkable. When you think about it, we're not just talking about small improvements here.
Now, this feels like a whole new era.
Yeah, whole new era of material science.
It really does.
MatterGen allows us to completely rethink, how we discover and design materials. And it could lead to breakthroughs that we couldn't even imagine before.
Yeah, and we've already seen some hints of that, like you mentioned earlier, with those more stable crystal structures.
Right, exactly.
The ones that are much more likely to actually exist.
Yeah.
It's like, MatterGen isn't just throwing out any idea. It's actually finding solutions that are grounded in science.
Exactly. And the fact that those findings are validated by those well-established scientific methods like DFT calculations just makes it even more exciting.
Right.
This means that MatterGen isn't just stumbling upon, lucky combinations. There's real scientific rigor behind its discoveries.
It's like having a superpowered research assistant that can not only analyze tons of data,
Yeah.
but also double-check its own work.
That's a great way to put it.
And that ability to quickly sort through all that data and find promising solutions is really important in a field like renewable energy, where we need innovation fast.
Absolutely. We're facing some urgent challenges, climate change, resource depletion,
Right.
and AI-powered tools like MatterGen could help us find solutions at a pace that matches the urgency of those problems.
It's like we're racing against time,
We are.
and this could give us a much-needed boost.
Yeah, it's almost like we're seeing the beginning of a new era in scientific discovery,
Okay.
where AI is no longer just a tool, but it's a partner in the lab.
That's interesting.
Yeah.
This idea of AI evolving from a tool to a collaborator.
Yeah.
But where does that leave human researchers?
Right.
Are we headed towards a future where scientists are replaced by algorithms?
I don't think so.
Okay.
I think the human element is still essential.
Right.
Even in this age of AI-driven discovery.
Hmm.
AI in its current form, it lacks that intuition, the creativity, the critical thinking skills
Right.
that are so important to science.
Yeah.
MatterGen might be great at analyzing data and finding patterns, but it's still the human researchers who need to interpret those patterns, design those experiments, and figure out how to apply those discoveries.
So it's not about replacing humans. It's about redefining the roles.
Exactly.
AI takes on that heavy lifting of crunching all those numbers.
Right.
And human scientists can focus on the bigger picture thinking and problem solving.
Yeah, it's all about combining the strengths of both AI and human intelligence.
So it's like we have this powerful telescope that can show us distant galaxies.
Yeah.
But we still need astronomers to interpret the data and understand what it means.
That's a great analogy.
And this highlights the need for a new kind of scientist.
Yeah.
Someone who's not only an expert in their field,
Yeah.
but also understands AI.
Absolutely.
These individuals will be the bridge builders,
Right.
the ones who can connect the worlds of humans and machines
Exactly.
to unlock new knowledge.
It's a really exciting time to be involved in these fields. We're seeing this convergence of different disciplines that could lead to some amazing breakthroughs.
And we've talked about the potential for revolutionizing renewable energy,
Yeah.
but this could go beyond that.
Absolutely. Think about medicine, materials, science, even space exploration.
Yeah, the possibilities are really mind-boggling.
There.
You mentioned earlier that MatterGen can design materials with specific properties in mind.
Right.
Can you give us a few more examples of how that works?
Yeah.
And what impact that could have?
Sure. So let's imagine we need a material for a new type of solar panel.
Okay.
One that can efficiently capture energy even in low light conditions.
Got it.
We could give MatterGen those specific requirements.
Yeah.
And it would analyze tons of combinations of elements, looking for those that could meet those needs.
Okay.
For example, it could identify materials with unique light-absorbing properties.
Okay.
Or explore different structures that maximize energy capture.
So it's not just about finding a material that works, but finding the best material for a very specific purpose.
Exactly.
Even if that requires properties that don't even exist yet in nature.
Yeah, it's like having a tailor for materials. We
Right.
can ask for exactly what we need, and the AI will create the perfect fabric, so to speak.
And that ability to design for such specific needs could have a huge impact across so many industries.
Oh, absolutely.
Think about medicine.
Yeah.
We could use AI to design materials for implants that are less likely to be rejected by the body.
Right.
Or materials that can deliver drugs more effectively.
Yeah. Or even lighter and stronger materials for aircraft and spacecrafts.
Right, less fuel consumption, longer distance travel.
Exactly. The possibilities are endless.
And as AI gets better,
Yeah.
and our understanding of materials science grows,
Yeah.
we can expect to see even more groundbreaking applications.
Absolutely.
It's like we're moving from an era of just discovering the materials that nature provides to actually creating the materials of our dreams.
I like that.
Designed exactly how we want them.
Yeah, we're shifting from a paradigm of discovery to one of creation.
It really is an amazing time to be alive. To see this incredible fusion of technology and human ingenuity.
Yeah.
But let's focus back on MatterGen for a moment.
Okay.
What are some of its specific achievements that really highlight its potential to change material science?
Well, one of the most impressive things is its ability to create totally new and unique materials
Okay.
using elements from across the periodic table.
Wow.
And this goes beyond just tweaking existing materials. It's about creating completely new chemical structures with properties that we've never seen before.
So it's like having an AI chemist that can not only replicate existing recipes, but also invent completely new ones.
That's a great analogy.
It's like expanding the cookbook of material science.
Yeah.
And this ability to create new materials is closely linked to its ability to target very specific properties.
Right.
Whether it's magnetic density, electronic characteristics, or even mechanical properties.
Exactly. It's as if we have this custom material shop where we can order exactly what we need,
Right.
even if that what doesn't exist yet.
And that level of control and precision is what sets MatterGen apart from traditional ways of discovering materials.
Yeah, it's a fundamental shift.
From slow trial and error to a very targeted and faster exploration of possibilities.
Absolutely.
It's like having a fast-forward button for material science,
Yeah.
allowing us to skip years of research and get to solutions much quicker.
And that speed is crucial when you think about the challenges we face today.
Right. Climate change, resource
Yeah,
depletion. We
seriously.
need solutions now.
Yeah, having a tool like MatterGen that can speed up the discovery process could be a game changer.
So MatterGen is more than just a tool for exploring science.
Right.
It's a tool that could help us solve some of humanity's biggest problems.
I couldn't agree more.
By speeding up material science,
Yeah.
MatterGen could unlock solutions to problems that have seemed impossible for so long.
And that's what makes this technology so exciting.
It's about more than just discovering new materials. It's about discovering new possibilities,
Right.
new solutions,
Yeah.
and ultimately a new future.
I think that's a perfect way to transition to the final part of our deep dive, where
Yeah.
we'll explore the broader implications of MatterGen and what it all means for the future of humanity.
Yeah, I'm eager to dive into those broader implications with you
Yeah.
and see what kind of impact this technology could have on shaping the world we live in. It's amazing to think that a tool like MatterGen could be the key to solving some of humanity's biggest challenges.
Hmm.
But it's not just about the science itself, is it?
No, you're right. The effects of these discoveries go way beyond the lab. Think about the potential for economic growth, job creation,
Mm.
a better quality of life for people around the world.
Yeah, like a chain reaction.
It
A
is.
breakthrough in material science could lead to all these positive changes.
Exactly. And we really need to consider these broader impacts as we move into this uncharted territory of AI. It's not just about the technology, it's about how we use it to create a more sustainable, equitable, and prosperous future for everybody.
That's a really important point.
Yeah.
It's not enough to just develop new technologies we have to make sure they're used responsibly.
Absolutely. And that's where the human element becomes even more important.
Right.
We need to think carefully about the values embedded in these AI systems.
Mm-hmm.
Are there any biases, and what are the unintended consequences that might come up?
So it's like we're not just designing materials.
Right.
We're designing the future.
Exact.
And that's a big responsibility.
It requires scientists, policymakers, and the public to all work together.
Yeah.
We need open and honest conversations about the benefits and the risks of these technologies, and we all have to make sure they're used to make things better for everyone.
It's a complex challenge, but it's also an incredible opportunity to shape the future in a positive way.
I agree.
Let's bring it back to MatterGen for a moment.
Okay.
We've talked about its potential, but can you give us some specific examples of how it could be used to solve real-world problems?
Sure. Imagine a world where we could create materials that are specifically designed to filter pollutants from the air and water.
Oh, wow.
MatterGen could help us develop those kinds of filters that are really efficient and affordable, leading to cleaner environments and healthier communities.
What about clean water access?
Right.
That's a huge issue globally.
Absolutely. Could MatterGen help us design better desalination plants or water purification systems?
Right.
Definitely being able to design materials at the molecular level opens up so many possibilities.
So we're on the verge of some really groundbreaking solutions.
I think so.
But with all this excitement, are there any potential downsides or risks to this technology?
Like any powerful tool, MatterGen needs to be used responsibly. There's always the risk of unintended consequences, and we have to be careful and think ahead. For example, if MatterGen is mostly used to develop products for profit, it could actually make existing inequalities worse and concentrate wealth and resources in the hands of just a few.
That's a really important point. We have to make sure the benefits of MatterGen are available to everyone, not just a select group.
This requires planning dialogue and a commitment to using this technology for good.
So it's a reminder that even though these technological advancements are amazing,
Yeah.
we have to guide their development and use them in a way that benefits all of humanity.
Well said, and I believe that with careful thought and collaboration, we can use the power of MatterGen to create a better and more sustainable future for generations to come.
We've covered a lot of ground today, from how MatterGen's algorithms work to the broader implications of this technology for society.
Yeah, it's been a fascinating conversation.
It really has, and I think our listeners have a better understanding of the power of AI now.
I hope.
So as we wrap up, I want to leave our listeners with one final thought. If AI can design materials with this much precision and efficiency, what other problems that seem impossible now could we solve? What incredible innovations are just around the corner? The possibilities really are endless, and that's something to be excited about. Thanks for joining us on this deep dive into the world of AI and material science. We'll be back soon with more explorations into the cutting edge of science and technology. Until then, keep asking questions, keep learning, and keep imagining the future.